Got it.
Got it, Easy Rider. Well, all right, we're live. We're also going to be recorded, but let's do number 99, guys. Welcome aboard, stargazers, asteroid occulters. It happens to be the 99th edition of Santa Barbara, California's longtime astrophysics and telescope club's weekly vlog podcast. We call it the SBAU Astro Hour, number 100 next week. Going to meet with Santa Barbara Astronomical Unit's Brain Trust each and every Monday morning through Zoom, 11 till noon, live from our individual computer rooms, dens, man caves, and talking about the cosmos. I'm your host, Vice President, proud to be reelected again, Ron Heron, number 99. Next week, number 100. Watch us on YouTube. Leave comments and questions in the bottom. This week, we're going to try to talk about a sprinting nebula, one that's running, my God, and a blinking one, with some open clusters and contact binary. Is that possible? Going to take you deep into space, gang. Saturn and Venus look like they're coming close together. Is that possible? One's inside and the other's outside. Well, we'll talk about it. The green comet E3 is in Borealis. Our sovereign stellar savior, ladies and gentlemen, the sun is very active. Well, we're getting very close, or did anyway. A growing list of new rockets and NASA space missions. Got it all covered this hour. Welcome aboard the 16th, January 16th, 2023 through the 22nd. Let's meet the man in charge, Jerry Wilson. How are you,
Good
Jerry?
morning.
6 years, you run a mean online meeting, let me tell you. We've had a couple in the past couple of weeks. Here's Chuck McPartland, our incredible, outrageously outreachable outreach coordinator. Wife Pat is not on the screen. They're both married to a Pat. Pat is our merchandise manager. And the dog, you want to introduce him? Somebody's dog.
That's Wally. That's Wally.
Wally is with his master, Tom Whittemore, who's married to Maureen, former Westmont College science instructor and editor of our glorious early in the month or late in the month for the following month newsletter. We'll be talking about, I guess, Mr. Bassi. Professor Joseph Bassi will be our speaker on the 3rd of February coming up. So, gang, enjoying the rain or hoping for better skies? Just curious. Any of you set up your telescope recently at all?
Not in a while.
Mine is all set up. I just have to roll the phone.
Okay, you've got to do you've got a new a little box type cabin observatory, right? Mr.
Yeah.
President, you talked about it in December. The other two of you just do it in your backyard, I guess.
I do it in the driveway out front.
Yeah. How about the silly science cartoon? I only have 3 listed, but maybe we'll be doing some that we didn't get to last week. Our president somehow has a source for these silly science cartoons. And
this week was a slow week for science cartoons.
that's true, but I finally got this one. When I said to myself, that's a Far Side cartoon, and then I realized that's what the joke is about. You seem to be suffering from farsightedness.
Yeah, that's pretty good.
That's
So we only have 3 this week.
okay, good. Then the eye exam, that's the, how about, is this gotcha or is this the format? 2 computers talking. One says to the other, it's New Year's, so what's your resolution? The other second monitor replies, same as always, 1024 times 768. You want to tell me what that's about so I get the laugh?
That's the format of the screen. It's how many pixels there are.
Okay.
Horizontal is the 1024, vertical is the 768. And
also say, at least it's not Y2K. Or you could say
no, but this is the old standard form for TV frames. We're much higher resolution now.
okay.
So
And those computers come complete with a red lens, and they'll say, Dave, let me see your drawings, Dave. Remember him? Oh, here we are inside the observatory. Gotcha. 2 green, ugly extraterrestrials showing up at the main inside door of the astronomical observatory, and they've got a cop with them pointing at the scientists working the giant telescope. Aliens accuse them. That's them, officer. They've been peering in our windows for years. My God. I don't think they do it that way anymore. Isn't it on computer screens, or at least from the side, not from the back end?
yeah, and I don't think there's ever been a telescope that looks exactly like that.
I believe Edwin Hubble looked through his like that, didn't he?
Hubble didn't have a telescope of his own. He used the Mount Wilson telescopes.
Well, that's the one I'm talking about, where he checked out.
In that one, you
Yeah.
sit in a cage up in the top. It's
Yeah.
a Newtonian type, not Newtonian, but Cassegrain design.
I guess they gave up a long time ago trying to warm those places because they got to open up and the warmth affects things, doesn't it? They
Yeah.
have heating.
Yeah, you
Okay.
wrap yourself up real well.
Or squirrel yourself away in a heated office.
Since the
Computer
both
screens.
the 100 inch and the 200 inch had a cage that the observer rides in. I had heard that there was a sign in one of them that said, if you feel yourself falling, try and fall away from the mirror.
Pretty good.
Well, the web is still giving us great stuff, and we had a great weekend and a great rain, and I guess there's another one due, right? Coming in this week. And
I think this is pretty much it for
it's the last river, atmospheric river.
yeah, I noticed that they're going to lose another chunk of the park up at the Ledbetter Beach. What is that?
Oh, Shoreline Park.
Shoreline Park. Yes, thank you. It's separated and started to move off, headed
Yeah,
to the beach below.
Pismo Beach, up where my daughter lives, has the same problem. The big crack, and they're expecting the cliff to go anytime, so they got a fence up around it. But my God,
A lot of water. Kachuma is basically releasing water, I think.
You think so?
Yeah, they're started.
They're at 88% last I looked, but they're releasing it just in case because they expect more downflow from the mountains still coming.
Yeah.
Wow, some of those big, huge reservoirs are already full too.
Yeah, upstream of Kachuma.
Yeah. Well, that's interesting. That doesn't mean the end of the drought, but we're going to go to the skies now. Is this the sprinting nebula, the running guy?
Running Man.
This is intro to the Running Man.
President Jerry is going to call up. He's our webmaster on this.
This is our finder chart. This is the constellation of Orion. Probably one of the most famous ones and easiest to spot. The M42, the Great Nebula in Orion, is down here. There's, of course, the three stars of the belt.
Right.
And then there's the sword. And M42 is the bottom star. M43 up here is the Running Man Nebula. And so one of our members, two of our members, Bruce Murdoch and Bob Richard, have collaborated on taking this outstanding photo and processing this outstanding photo of both of these, M42 and M43. This is the Great Nebula in Orion. And normally when we take a picture of this, the contrast, the brightness difference from this region out here and in the core is so strong that you can't in a single shot get both of them like this. This one is usually washed out completely. Yes, I put an R in wash. My mother was Midwestern. I picked up some of her pronunciations. This is the Running Man nebula up here, which we're talking about now, right next to the most famous. Most people look at this and don't really notice this. It's visually, it's not that hard, not that easy to see, but it makes a very nice image. So you can see both kinds of nebula in here, blue and red.
And nebulas are star factories, right?
Nebulas are clouds of dust, and if they get dense enough, they can collapse into, they can gravitationally collapse a portion of the, and turn into globules, and then the globules collapse into solid bodies. If there's enough mass, it becomes a star. If there's not enough mass, it becomes just a rogue planet.
So some of those big places out there are both, right? There's still lots of gas, so they're nebula, and in the middle of them is a star cluster of what, hundreds that have formed?
Yeah.
Checking it out. Can we see this with the naked eye?
You can see this one, it appears to be a star.
Oh.
You probably with binoculars, you can tell there's something there, but you can't see the nebula that well visually.
But seeing that big one as a star, it's not part of Orion though, right?
Part of the sword, Ron.
What?
Yeah, this is
It's there, but it's not one of the stars in the belt or anything like that.
Yeah, it
And the
is.
sword. It's the tip of the, it's the one up from the tip of the sword.
Oh,
Yeah.
so it's not even a star we're looking at.
See, but in this picture, which is a computer generated image from the Sky 6, M42 is that big nebula, and that's right here. And this is what it does look like to the naked eye. It looks like a star.
They call the stars Orionis. There's 42 Orionis, 45 Orionis.
Messier 42 and Messier 43. They don't have the word Orionis after them.
That's
Oh,
for
well.
stars, Ron, not for nebulae.
Yeah.
Well, I wouldn't have written them down if they weren't in your talking points. Magnitude 5, barely seeable. Okay.
Yeah, you can see on a clear night, you can see, most people can see to magnitude 6. Some claim magnitude 7, and maybe they do.
And a combination, it says in your notes, of emission and reflection. That
Yes,
means
those are what I've referred to as the red and the blue. Or the red,
the red and the blue. Okay, got it.
So the red is hydrogen emission. The blue is reflection nebula, where the light bounces off of the dust particles.
And there's some green emission from oxygen.
Yeah.
Wow.
And when you look through there, it's bright enough that you can almost see color. Some people can see it if you have a big, fast scope. You can get a hint of, it usually looks green, but if you can see a hint of red in it sometimes.
Well, I once saw at a Saturday night star party on Chuck's computer screen, right there on your Orion, I saw a big band of pink.
Yeah.
I'm sure
Yeah,
you
we-
didn't add it. It wasn't artificial. It came from space, right?
Yeah.
That's what you're seeing as red in this picture.
Yeah.
Is that right? Same thing you
That's-
had there.
That's the brightest line of hydrogen, the hydrogen alpha line. And right in here is a little cluster, a little, what is it, asterism, called the trapezium. It's a set of 4 stars visually or 6 stars in a scope. You don't see it visually without a scope, but 4 to 7 stars, depending on how acute your vision is in a small scope. And if you take a picture and you can get through all of the dust of the nebula, you can see a lot of stars in there.
But is there a drawing that Chrissy Cook throws on the ceiling of the planetarium of a running man around those upper stars there?
Yeah, this is the image of the running man.
I'm sorry, but it doesn't look like it to me.
It's a nebula, Ron. So you'd put up that almost this picture on the planetarium. It's not a constellation.
It's
Yeah.
an asterism.
It's
Yeah,
not an
this dark-
asterism.
It's these dark lanes in here. It has sort of a human shape. Head, arms, legs.
And they were made of that same dust that's around them.
It's in front of the blue.
Oh, it's in front of the dust cloud. That's way behind it then.
The blue cloud that shines by reflection. Yeah.
Tom Whittemore, you got any comments?
No, not for that. I've seen a lot of color detail in M42 in my 18-inch telescope. And that's just a function of you have a really nice light grab. And so it's exciting your color sensors in your eyes. Okay. That's amazing image. Beautiful image.
Yeah, this image was taken by the team of Bruce Murdoch and Bob Richard, and it was processed them. This is a short exposure picture to capture the core regions, the really bright region, to get the detail in here, and then a long exposure to get all the other stars in the fainter regions. And in the long exposure one, this is completely washed out. So it was changed by masking it out and then superposing the other one into it.
I see.
So it's a stack of many different exposures, or not many different exposures, many different frames. Probably 2 different exposures. So it's an excellent picture.
I enjoy it. I learned so much. Let's go. We got a lot to talk about.
This is a picture of just the Running Man Nebula.
Uh-huh.
actually a little Tyrannosaurus down here, but that's just my image.
You know the number of light years away that happens to be because it's not listed.
That whole region is in the neighborhood of 1,400 light years away, that molecular complex.
I'm sorry, gentlemen, that's a long way away. If it took the light 1,400 years to get here. Can we go to magnitude 5 M35? Following your talking points, Mr. President, and this is an open cluster.
Oh, this is where we are.
Oh, it's the same sky, moon is.
No, it's just a big black frame, but it's a different constellation.
Oh,
so Orion is now down here. There's M1, a supernova remnant. We're looking here now at this one at M35, which is an open cluster over here. And the reason, go ahead.
Oh, what's an open cluster? What does that mean? How do you define an open cluster?
It's
young stars loosely gravitationally bound.
Yeah.
So they're orbiting around each other, but there's no threat of they're ever colliding. Or
no, they're all orbiting the core of the galaxy, but they are loosely gravitationally bound. So they're changing their relative position next to each other, but they're not really orbiting each other.
Oh.
In a globular cluster where it looks like a small compact ball, they are orbiting a common center, sometimes even a black hole at the center of the globular cluster. There's no black hole at the center of an open cluster. These are stars that have just formed from the gas of a nebula, and they have turned on and blown the nebula away.
And this is in Gemini.
Yes, this is the constellation of Gemini. There's the two twins. This is at 7 p.m. shortly after sunset on January 18 for this one, but it won't change won't change during the week, except that Mars will move.
Yeah. So Ron, it's down near the ankle bone of one of the twins.
Yeah.
Propus, I believe, means ankle, right, Chuck? Propus.
Yeah, I believe so.
Yeah.
Propus.
And the whole thing, M35, is about as big as a full moon, about half a degree across.
Yeah, it's quite large.
You can see it with the naked eye.
Yes, in a good sky, you can see it easily with the naked eye, but not its companion.
Yeah.
Well, it's not really a companion. It's just way in the distance.
So this is M35. See, it's an open cluster. This, on the other hand, is a much tighter cluster, and that is, someone help me out here. I've got it wrong in one place, but I don't remember which one.
2158, Jerry.
Okay.
You're talking about the little spot on the lower right?
Yeah.
It's just very far away, and the stars are older.
And this is, you can see the color difference. Also, this is considered an open cluster too. It's not, even though it's more compact than this. So
yeah, you can see it's more reddish. Older stars are redder.
Yes. Good point. Yeah, I think the stars there in general about 2 billion years old. So old, half as old as our sun, but old.
Now this picture was taken with a 4-inch refractor.
4-inch.
Takahashi FSQ 106. And an older camera, an SBIG.
Santa Barbara Instrument Group.
Yep. I used to be right down here, about one freeway off ramp away from my house. And it was nice to drop over there and talk to people.
Yeah.
They had a 6-inch Unitron refractor set up in their lobby. But they moved out of town. Excuse me. But they moved out of town.
Yeah.
I think they're owned by a Canadian. Oh, go ahead.
Go ahead, Chuck.
I think they're owned by a Canadian group.
Okay. I was just going to mention on M35, the sparse one there. I always point out to people, especially the 8-incher Westmont, there's kind of like two opposing arcs of stars there. I don't know if you can catch that, but it's really pretty. It's like a flower opening up almost.
Well, that's 2,800 light years away. And this is interesting. It's coming at us at 10,800 miles per hour.
Not very fast. You know, 17,000 miles an hour is orbital speed,
I
and
know.
our
Yeah.
rockets generally attain that.
How fast is Andromeda coming at us? Can you put a figure on that?
Oh, it's something like 200 kilometers a second.
Oh,
Yeah.
it's a little faster.
Yeah,
Lord.
billions of years until collision.
And the photo is M35 and NGC 2168. That's the little one, right?
No, 2158 is the
Yeah,
little one. There's a
58.
typo.
Oh, it's a typo,
Yeah.
which I wrote down. It's like,
Mhm.
On the caption, apparently, I put in 2168. It's 2150.
But I think what Chuck pointed out was really neat, the fact that, 2158, the one in the background on the lower right, consists of mostly aging stars that are golden and red. Whereas you see 35 and you can see these bright blue giants, just sparkling out of the black background.
huh.
With a couple of reddish ones sprinkled in that are
Yes.
a little bit older, a little bit more massive.
Mhm.
But most clusters are orbiting among themselves. They're like little mini versions of the galaxy inside a
That's a
galaxy.
globular cluster, Ron, not a galactic cluster like this or an open
Oh, and
cluster.
that's where the
Yeah.
word open comes in. Got it.
Mhm.
Well, are we heading northwest instead of east to Cygnus the Swan to talk
We're
about?
heading west, way to the west. See what time this is. No, that's still 7 o'clock on the 18th.
Okay.
So I don't have the horizon in this, but
Yeah.
it's getting close. The thing is that here in the Swan, now swans, if this were the hawk, then this would be the neck, but it's not. This is the swan, so this is the neck,
Mhm.
and this is the tail, wings. I don't know where all this extra crap comes from, but anyway.
I see
The,
Deneb right there in the
what's
middle.
that?
I was looking for Deneb, and there it is.
Deneb, yeah, and
Yeah,
albedo.
yeah, tail in Arabic.
Uh-huh. So this one, this cursor marks the spot of a planetary nebula called the Blinking Nebula.
Mhm.
Blinking-
Tim Crawford favorite.
Yeah,
So it's got this habit of almost like variable stars.
no, this is not. The nebula and the star in the nebula, the core nebula, it shines steadily. There is no variability to it.
Mhm.
The blinkingness is an artifact of your eye trying to look at it. So this is what the nebula itself looks like. And of course, this is steady because it's a still frame. But even if it were a movie, it wouldn't be changing its size or changing its brightness. The star, it looks one way if you look directly at it. The nebula disappears because
Mhm.
you're using your central color part of your eye, where you pay attention, where you focus when you read. You look at the star, and if you look away from it and use averted vision, then the nebulosity will pop into view. So as your eye goes back and forth from looking directly at it to looking offset from it, it appears to blink in and out of being visible.
Well, I got
It's purely an effect of your eye.
I got
Right,
news
your
for
eyes
you.
doing tricks.
Well, that happens to me on almost every star I look at, unless it's really bright, like Sirius. I got to look off to the side before it comes into something about the center of your eye, where the optic nerve, I guess, comes
Well,
into
it's
the
not,
retina.
it's not the optic nerve. It's your fovea where you have your daytime bright light and color sensors.
And Ron, remember that this is a a dying star. So that middle star there is a white dwarf. Okay. So this is like the fate of our sun sometime, way in the future.
Well, I wonder who named it blinking. Is that the ancients? Were they
No.
looking at-
Oh,
You need a
no.
telescope to see this, Ron.
You need a
Yeah,
scope to see this. You need a telescope.
That's a recent name for it, and it's not an official name. It's just a colloquial name that amateurs use.
Yeah, and one joke. So this again, I mentioned this, a Tim Crawford favorite, and it's very close to a star in Gemini called Wasat. And every time Tim likes to crack a joke at Outreach, he says, "Wasat." WASAT.
Oh, it's an optical illusion.
Yes. Mhm.
It's not listed on here.
No, okay. It's the close star to the nebula.
This
plants
one
are-
right here.
Probably one up.
Yeah, it's pretty bright, Jerry. That's probably it.
Okay.
The
Tim-
cones,
Tim is-
the rods
Tim
on our
is-
eyes, the rods on our
Uh-oh.
eyes are 1,000 times more sensitive to light than are the cones.
Oh my God, we're inside the hospital with Bruce. Bruce,
I had
How
a
you
nice
doing?
breakfast, a big omelet, all the fixings.
well, we're so glad you didn't flatline on us.
Now,
So am
as
I.
Bruce's evidence, we found out that amateur astronomy is a contact sport.
Go for holes.
Yeah.
Well, I almost said earlier that you were in the hospital and you couldn't join us, but you were on for a while. But then I thought, no, that's private. And now here he is live from Cottage Hospital.
Oh, he's welcome.
Yep,
All
on
right,
my
also-
cell phone.
Well, real quickly, you want to tell us what you guys over at the Theater Organ Society you're doing in town real quick? Give me a date.
Saturday, June 21st, open console from 9 until 11 a.m.
Downtown at the Arlington.
at the Arlington Theater, 1317 State Street.
Okay,
It's open to the public. Come down, listen to the organ, play the organ. We'll show you through the chambers where all the pipes are, where all the
Okay.
sound is made.
okay, no charge.
No charge, free to the public, free to everybody.
But I just heard you had to double your sign-up fees for the club. It's now $10 instead of $5. All right,
That's,
thank you for
that's if you
joining.
get the email message, the email newsletter. If it's
Ah.
mailed to you, it's $20 a month.
Oh, it's 20.
Not a
Okay.
month, a year.
Yeah, well, that's us. Okay, you joined us in the middle of the optical illusion. Are we done or are we going to go to Saturn and
We're
Venus?
moving on to a golden opportunity for a photo op.
Oh, yeah?
This is to the west southwest at 6 p.m. on January 22nd. The date and time was chosen because this on my planetarium software is about the closest that Saturn and Venus look like they're going to get to each other, which is less than a degree. So if you put a small telescope on it, you will get a very nice picture. They're very, very bright. They're very different in brightness. Venus is very bright. Saturn is not so bright. But you can see the rings. You can capture that. And Venus is almost, I think it's 97% illuminated. So it's almost full. Saturn, of course, is almost full too, but it's much farther away.
Well, they're both on the far side of the sun, basically.
No, Venus is on the far side of the sun.
Mm-hmm.
And
then so
Saturn is getting there.
Saturn would have to be on the far side too. It can't be behind us.
No,
It's
no.
kind of it's always
Yeah.
on.
And it's way out there. I mean, it's as far from Jupiter to Saturn as it is from us to the gas giants, isn't it?
Yep.
Okay.
You should be able to see Saturn no matter which side of the sun it's on, because it's behind us.
Yeah,
It's a big,
Yeah, that's why I giggled.
Look how close
That's why it
they
doesn't
are.
go through phases. Yeah.
right.
At least not much.
They're that
I'm
close.
taking this picture, the moon, heading toward new moon. We're past the last quarter. Yes.
Yeah, it's going to mention Jerry Dana Belgetti must be in Capricorn because that means the goat's tail.
Goat's tail. Okay.
Any Algetti is about a goat.
What does Deneb mean?
Tail.
Tail. Okay. Oh,
Like,
that's
yeah.
right. Deneb, the star in the swan.
Right, like in the end of the lion, Denebola.
Yeah.
Yeah, the little tail.
Okay.
Well,
So
now,
anyway, get your scopes and your cameras out, and we expect to see some good pictures next week.
Provided it isn't
22nd?
raining.
That'd be pretty nice binoculars, huh, Chuck?
Now we
February
have
1st.
the green comet.
The green comet. Why is it green? Why did it turn green on us?
Diatomic carbon.
Yeah.
We didn't see it before. C3.
No, it's been green for a while.
Oh, has it?
Yeah. I chose the time. I mean, this is off the web, but it's set for February 1, 23. I put it up because I think this will be a good time that the rains are over here. It's 2 weeks from now.
Wow.
And So this is Polaris. It's going to be visible to virtually everyone in the northern hemisphere.
Very
And
nice.
the tail of Cygnus is way over there.
Mhm.
And Castor and Pollux, the twins, are down here. So the blinking nebula's off that way. Okay, my cat just came in. Okay.
Well, Jerry, that wasn't the blinking nebula over there. The blinking planetary is more over toward Deneb and very low. And that's M35 is more over.
Oh, that's right. Okay, yeah. See, my short-term memory again.
And this is closer also to its closest approach to the Earth for ZTF here, E3.
Yes.
But now my understanding with my short-term memory from last week is that this sucker takes 50,000 years to go completely around the sun in its orbit.
That's an
And-
estimate, yeah.
So in its far distant orbit in the Kuiper belt or out in the Oort cloud, it's really got to go super slow, or it should stay a few thousand years with us. Would you think?
No, run in an orbit. The farther away you are from the focus, that you're going around, the slower you move. So it moves very slowly.
I understand that, but I'm using 50,000 years. How could it come by us in just a few months and then spend 49,000 something years out there?
That's just the math of its orbit.
Is that right?
Things speed up when they get near the sun.
They
it's
sweep out
going out,
equal
so-
areas. They sweep
What?
out equal areas in equal time. So when it's close to the sun, it's got to move a lot faster to get the same area in the same time than when it's way out.
Yeah.
Well, it supposedly swung around the sun and it's on its way out. And were we watching this when it was coming in?
Yes.
We were.
Yeah, we've been
We had
watching it for a
pictures
while.
of it the last couple of weeks.
I know it's labeled 2022, but that's one silly
That
year.
was when it was first seen.
I mean, it's been
I mean, the Neanderthal calendar may have a different, designation, but we don't know that. So anyway, here's the green comet, the green coma, and here's the nucleus. White off this way. Ions. Which one's the ion?
That's the ion tail. It's
Okay.
it's the
And
triple
this is
ion
the dust
tail.
tail.
Yeah.
Wow.
And there's a satellite or an airplane going through, probably a satellite.
Where?
See, there's a very faint line right there,
Oh,
my cursor.
so that's an
Wow.
open lens for a few open shutter.
Yeah, this is a very good photo, but it tells me it's a single frame. It's not stacked, and since the comet moves, it would blur the comet if you did a lot of stacking.
Now it's heading toward Draco, the star. Is that in the Borealis constellation?
Draco
No.
is a constellation, Ron.
There's-
Draco the dragon.
The dragon.
Not a star. Okay. That's why I'm here. I'm learning. See it best early in the morning before dawn.
Okay,
All right. On we go to the sun, active to the point of danger or just regular sunspot?
no, just
activity?
active to the point of interest.
Okay.
Lots of features. It shows just about everything that's going on there. You have
That's a
prominences.
fantastic photo.
Yeah,
All the little blurbs on the surface are promontories or what do they call them?
Prominences.
Prominences.
yeah. The things sticking out are prominences. They're blotches of they're magnetic fields that are thrown out of the sun. They go up and come back down. Because remember, magnetic fields are all closed loops.
Mhm.
They don't have a source and an end. And when they go up, they cool the very hot solar surface or surface atmosphere. And then that cooled hydrogen emits light as it falls back down.
Huh.
And
And
the
when you
dark
see
lines
this-
you see that look kind of like blood vessels in places, those are prominences too, but you're looking at them from the
Yeah.
top. Yeah.
Well, is there one sunspot in the middle?
No, this is a sunspot. The white areas in this picture are sunspots.
Really?
Those are plages. They're
Yeah.
areas around magnetic activity. And then when you see a dark spot in there along with them, that's what we call
Yeah.
sunspots. But they are all
Right.
sort of the same thing.
Yeah.
Mhm.
And they're caused by the lines of force of magnetism.
And
Yeah.
you can see the surface granulation in this real well. That's a high resolution picture.
To me, it's always been curious why they call them plages, because that's French for beaches.
Yeah.
Huh.
Really?
Well, if they have oceans on the moon, mare,
Yeah.
why
Yeah.
not?
Sur la plage, on the beach.
La plage.
Now, is this part of the 11-year cycle of sunspots when it gets high or low, or
Yes, we're in a right into a maximum.
Yeah,
this is the maximum time?
getting
So
a lot of activity.
it'll settle down in years to come.
The sun does not offer or rotate as a solid. It has different rotation rates depending on its latitude, and that twists up the magnetic field lines until, like a rubber band, if you keep twisting it and twisting it and twisting it, it starts distorting, and knots of rubber bands start sticking out. And that's exactly what happens here. Magnetic field lines get twisted up and they start getting pushed out of the surface of the sun and lifting all this hydrogen with them.
Yeah, and Ron, just to give you a feeling for the speed, so in the equatorial region, the sun takes about a month roughly to go around once. But up towards the poles, it's more like 36 days or more. So it's slower up top, faster in the middle.
Wow, it's like taffy, having a taffy pull.
Yeah, it's not a solid body. See, it's not a solid body. There's differential rotations, the fancy phrase for what goes on.
Isn't it the same story with the gas giants?
Yep.
Yes,
Even more so, some stars rotate so fast in the center that they are ovals.
right. One of those is Altair in the Eagle. Rotates really fast.
Sort of football shaped.
Yeah, it's got a bulge.
And they can rotate so fast that they pass their own Roche limit, and they throw off material out into space, so that they fall back to being just the shape, the maximum shape they can be, or they lose material.
Well, being in a little closer by a couple million miles recently, did that affect us at all?
Go faster.
No, there are no ground
When
orbits anywhere, I guess.
we are in a very slightly elliptical orbit around the sun, and
Right.
as you point out, we're a little closer. We're 1.5 million miles closer than the average of 93 million miles.
Yeah.
And so the sun looks a little bigger than it does normally, not so as you'd notice. But if there's a total eclipse of the sun, which there's one coming up, we'll talk about it next week,
Right.
the moon will not be big enough to cover it completely.
Yeah, I was going to mention, Ron, that the other day, January 4th, when we were the closest, our dog Wally complained of whiplash.
Where is that solar eclipse going to be? Can we see it from here?
We'll talk about it next week. I've looked at so
Okay.
many pictures, they're jumbled up in my head.
The New York Times posted several weeks ago, this is going to be a year of solar eclipses. Well, there's our gas giants. Plus one
Yeah,
visit.
this is
Upcoming missions.
upcoming missions of 2023. This is just the ones that NASA's involved in.
This
Other
year.
places like India and maybe even Turkey and China and Europe are having their own space missions too, which I'm not covering here. But the what you're seeing, the picture here represents the JUICE mission, the Jupiter Icy Moons Explorer mission. And this started back in the 90s as with a proposal from NASA called the Jupiter Icy Moons Orbiter. So this is going to launch between April 5 and April 25 of this year.
Okay.
It's a collaboration with the European Space Agency, and it's going to lift off from Europe Spaceport in French Guiana. It's going to explore 3 icy moons, Ganymede, Callisto, and Europa.
Not going to land, is it?
No.
Not this time, I don't think so. The plan with Jumo was to land on Europa, which is believed to have an ocean in it. And they were going to drop a nuclear reactor on the surface of the ice and then let it melt its way through the ice and straight stringing a cable out behind it would be used to broadcast information back to Earth.
Whoa. See what
I don't
kind of
know if
future-
that was quite expensive. I'm not sure they're going to do that on this thing, but they're going to at least whatever it explodes. Artemis 2 will have its astronauts. It's down to 18 hopefuls for the Artemis crew mission, which is at Artemis 2. Artemis 1, you recall, was launched a couple months ago. The crew, it'll be named in early 2023. I think it's just early, it doesn't give a month. And the Artemis 2 mission is expected to send 4 people on a trip around the moon and back to Earth. Artemis 3 is the one that will aim to land astronauts on the lunar surface for the first time since the 20th century.
That'll be in 25, you think?
Don't have a date for that. They're quite uncertain. So, but I think they'll be getting better at estimating these dates. There's also a cargo to the moon mission called the Commercial Lunar Payload Services, CLPS. And it's going to rely on partnerships with more than a dozen companies that are privately developing their own lunar landers. The first to get up there and deposit materials and tools and components to build a lunar base and do more exploration. The first lander to fly into the program could be the one built by Pennsylvania-based Aerobotics, which is slated to use its Peregrine lunar lander. It's going to get 11 science and exploration instruments to the lunar surface in the first few months of 2023. And it will land in a large crater called Lacus Mortis on the moon. There are also 3 other CLPS programs that are going to take off in 2023.
Are they landing on the South Pole?
No, Lacus, that one's not at the South Pole, but some of these I'm sure will be. Also, Boeing is going to test its first crewed, not C-R-U-D-E, but C-R-E-W-E-D, first flight with a crew to test to the ISS. Boeing's been working for a decade to develop the taxi, I guess, spacecraft. Yeah, space taxi, and so it's finally up and running this year. It's also scheduled for their first flight in April of 2023, but it will be uncrewed. The first flight will be uncrewed, and then later they'll want to
Wow.
Yeah.
Bruce,
Okay.
did you have a comment, Bruce, from your bench?
No, I'm back, but no,
Okay.
just watching.
You're
Then
alive.
we're only halfway through NASA for 2023.
Well, there's a bunch of stuff.
It's going to be a very active year. We're finally going to get the Psyche mission off for the Psyche asteroid, which is believed to be basically a solid metal asteroid. And they're going to explore that. It looks like this is such a blur to our ground-based telescope. So it may be the leftover metal core from a planet, and it's therefore very interesting to see what the heart of a planet like Earth might be like.
Huh. What's that called again? That mission?
Psyche.
Spike.
This is the Psyche spacecraft in an illustration with the asteroid Psyche shown below it.
And you can see how closely related this spacecraft looks to the JUICE mission with those big
Yeah.
cruciform solar panels.
Huh.
Now there's also going to be the first launches of new commercial vehicles, which continues the recent trend in space. These are entirely owned and operated by the private sector. SpaceX will be expected to attempt the first orbital launch of its gargantuan Starship aircraft, which is also, NASA's also relying on this Starship for part of its Artemis program. 2 other powerful commercial rockets are also in the works, the Vulcan Centaur, developed by United Launch Alliance, and the New Glenn, which is a product of billionaire Jeff Bezos' space company, Blue Origins.
What if that's somebody, or does that stand for something? Is that an acronym, Glenn?
John Glenn.
No, it's John
Is it
Glenn.
John Glenn?
Yeah, it's spelled like a name.
Yeah, right.
They're going to launch, one of these is going to be launched from Florida, and the other one, amazingly, is going to be launched from Alaska. I haven't heard of any building of a spaceport in Alaska yet.
Neither have I.
We've also got the asteroid samples heading back to Earth from Bennu, and they are part of the OSIRIS-REx program. It's expected to drop it in the Utah test range in October. Oh, sample from October, September 24th, excuse me. It's sampled Bennu in October 2020. And then there's a list of a whole more science missions to launch, but don't know the specific dates.
The Bennu sample is much bigger than they were expecting too. They ended up, I think, with kilograms when they were expecting only a few grams. So they really chomped off a bit of it.
They're going to land it in the desert using parachutes?
Mm-hmm.
Yeah.
Wow.
Years ago, I think the Japanese did, or someone landed a sample back in the desert on a parachute, and the parachute failed. And so the spacecraft, the sample return mission, impacted.
That was the comet return.
Let me,
That was
The
what?
aerogel. That was the mission that
Yeah,
went out and
that's right.
collected comet pieces using the aerogel.
Aerogel.
Yeah.
I kind of like the way they dropped one of the rovers on Mars with huge blown up balls filled with
Yeah,
air.
our spacecraft are now too big to do that. That was only the smaller rovers.
Oh, is
So,
that right?
yeah.
It was just fun
We
to see.
won't go into detail, but there's about a dozen more scientific launches going on too. This
Oh, there it is.
this is a picture of SpaceX's Starship completely stacked for the first time. It's stacked. They've stacked it a number of times, but this time they're going to fuel it to full capacity. So not necessarily launch it right away, but it will be launched probably sometime around May or June, I hear.
Yeah, but they call it a Starship and it's only going to Mars.
It's close enough for now. They are having problems with it. The static test firing they've been doing on it is causing more damage than expected to the stand that holds it up. They use special refractory concretes, and apparently they're not enough, so they're rebuilding the base again to beef it up.
Plus, most of their test launches have resulted in pretty large explosions.
Yes. It reminds me of the phrase from work at Raytheon was that success is built on failure.
Yeah.
So you got to get the failures out of the way.
But,
So
my understanding, to go to Mars, they're going to have something that slings the astronauts around with centrifugal force to give them artificial gravity, aren't they?
they'll just rotate a Starship.
Is that all? So
Starships are one configuration of the Starship is the outer wall is a floor.
the floor.
Rotate it as they go.
And they can
There are
go
also
around.
ones where they'll dock two Starships together and rotate them around as a long tube. So there's a number of approaches, but yeah, the gravity's a problem. This is the section now we're going to go to contact binary.
Oh, yeah.
Now this is a binary, and I haven't been able to find out where it is, but it is referred to as KR00245. And you can find a lot of references on Google to that, but nothing that gives the RA and declination. It is also called, not on that one.
Called NSBS 2983-201.
Yeah, that's it. Thanks. Rolls right off the tongue.
Sure, I just happen to know that.
So, but there are a lot of measurements of it. It is a variable star. It started out as a variable star, slightly different heights here, but modeling, they've looked at it for quite a while, and modeling has come up with this. This is the shape for the variable star. And what it is, it's a double star that rotates around it. They take turns occulting each other. This is the one on the left is at a phase of 0.75, which means that it's 3/4 of the way around from the 0 phase position, which is looking end on at the smaller star. And then the other one is
looking dead on.
yeah, and so this is phase 0. Now, the deal is that you can, when you have two bodies orbit each other, you can tell, obviously, the period, you can tell the mass and spacing of them also. And these have a mass of roughly the same as our sun. And that gives us a range of sizes that all lead to they're in contact with each other. So they orbit very fast, and with a massive object that size, there's no other option but that they're exchanging material.
Orbital period of 0.286 days, which makes about 3 hours to orbit each other, right? That's why they're connected. And are they going to unite and send out gravitational waves and become a black hole someday, you suppose?
That is the realm of black holes only. The let's see.
Not big enough to make gravitational waves.
No,
they're making gravitational waves. We are, Ron, but they're just not detectable.
Yeah, right. Bingo.
Okay.
Words right out of my mouth. So it is a short period variable. It has a mass ratio of 0.36. And
what does that mean?
Orbital period of 0.3 days. So that's about basically a third of 24 hours. So
That's
8 hours.
8 hours.
Yeah. And the system is 4,250 light years away from us.
Wow.
And based on the estimated, the absolute value, results together the system. They believe also they found a large circumpolar star spot assumed to be of magnetic origin that's on the larger body. But what they're going to do is the one with the most gravitational mass here is going to draw, at this point, it's going to draw matter this way until it reaches an equilibrium between the two. So it's not going to be a spectacular collision.
Oh, they're going to collide, but they don't know when.
No, it's not going to be a collision.
Oh,
They're already in contact. They're just exchanging mass. And their system dynamics will change as the mass changes.
So they'll gradually become one big star?
That I don't know. They didn't mention evolution of it. It could become one big star. It could become a star with a ring around it or something exotic. Be interesting to see that.
I found the Aryan deck. It's 1842 plus 64.
Okay.
So that's pretty northern.
Mhm.
Let me see if I can find the constellation here.
Mhm.
And we don't have a lot of contact binaries to report out there, do we?
I think this is the only one I know of.
Well, I've seen binaries, or at least pairs of stars where one of them is a super dense white dwarf, or maybe even a black hole that's squeezing stuff out of its regular star companion. That's contact, isn't it?
Kinda, but it's one where one is exchanging data or exchanging mass, and it builds up. Those are periodic novas where they exchange mass to the until it builds up enough hydrogen on the surface to explode again. So it's a recurring nova.
Wow.
This is nowhere in that mass range that does that.
Contact binary, the only one.
Did you find the constellation yet?
I'm working on it here.
Okay.
Oh, shoot. I'm trying to put up, labels, celestial guides, and it's putting it in degrees instead of,
Yeah.
all right, let me get rid of this.
Found by Polish astronomers.
The Polish astronomers were the ones that measured this. I don't think that was discovered. The contact binariness was discovered, but it's sort of been known as a short-term variable.
Wow. But it definitely takes a strong, powerful telescope to see it.
Mhm.
Yeah, that distance, it must.
Bruce, you're not on a ventilator, are you?
Oh, no.
Okay. Any comments, gentlemen? Tom, at the bottom of my screen, Bruce?
Oh, no, we're waiting for the,
If they want to weigh in.
It looks like it's up in,
Eureka? Pretty far north, huh?
yeah,
So when you think Polaris from this 90 degrees deck, this is 64. That's about 30 degrees away from the pulsar in a way.
yeah.
Probably.
Draco's in, but Draco's at 16. Of course, it's an area that's just below our horizon right now.
oh,
In the
good.
north.
But now the
16.
possibility, a probability of this sucker, these two having exoplanets is probably nil.
No, it planets far enough away will just see one center of mass and they'll rotate around, they'll orbit around it.
Really?
Yeah.
So
I'm going to guess Draco just from what I got, but
Okay.
it's pretty clumsy,
Okay.
so don't count on it.
Mhm.
So this is not a dim star. This is a magnitude 4.7 and 4.56.
Wow.
Two
Is that-
object.
Is that apparent magnitude or?
It says absolutely you're right. That's not apparent.
Oh, okay. So that's how bright it would be if we're about 30 light years away.
Yeah. Yeah, they don't give the
Yeah, because you said 4,000 something, right, Jerry? That's
4,000 light years. Yeah.
that's pretty far out.
Yep. Yep. So it's not going to be a very bright object at all.
No.
well, your note said 4.71 or 4.56, gave us two 4,000 numbers.
Yeah, but you see above it, it says absolute magnitude.
Right. So absolute magnitude, Ron, is how bright a star would appear if it's about 30 light years away. Technically, it's 10 parsecs, which is about 33 light years.
And as far as being
Just Ron, just another idea here. So if you took our sun and magically grabbed it, okay, and put it out at 10 parsecs, 33 light years, it would be about a fourth magnitude star, somewhere in that ballpark.
barely visible by the naked eye.
No.
Well, no, that's pretty bright. You know, you could see it with your eyes.
Oh,
Yeah.
our sun, yes, but not these stars. These
No,
would be way
no.
too dim.
No.
Okay.
We can see magnitude 6, can't we, with our naked eye?
On a clear night, yeah.
Good night. Good night.
And with
Yeah.
young eyes.
In Utah desert, you can see about 7.
Yeah.
Well, it's one thing to learn about a contact binary. Your assignment is to get a picture, all of you, of it with your telescopes within the next 7 days. Okay, gentlemen?
I think it's pretty dim.
And also, rain is predicted off and on for the next week at least.
No,
Yeah,
we're
pretty
going
light
into a
rain, I
dry
think.
period.
What is that?
We're going into a dry period.
Oh,
Yeah, it looks like I'm looking for Thursday as being the first clear night.
Okay.
We got all
Actually,
that water saved.
Tomorrow morning might be clear. I've got a couple of asteroid occultations at 3 a.m. that I might be able to give a try at.
Good luck.
Okay.
Good
Then you
luck.
can report
Yeah.
in next week. Appreciate it. Bruce, you're going to be in that room for a while, or are you getting discharged today?
I get discharged at 3 p.m. this afternoon. I'm just an observation. They want to make sure that the stuff they injected into me isn't going to have any bad results, and then they're going to extract it and put more of it in, and I go home.
Okay, so we won't be guilt-ridden if we don't visit you in your room then, will we?
I'm not in. I'm up in a surgical suite in a holding area.
Well, get rid of it, whatever it is.
Sure.
Yeah.
don't contract XBB, gentlemen.
Okay. Well,
Take
we're
care.
over our time.
Okay,
We
Jeff.
are out of time, but it was an awesome.
Yeah.
Next week, somebody's going to have to bring the cake with 100 candles on it. And I'm going to have to put this into a yearly series, 52 weeks in a series, and we're going into number 100. So we've been doing this for more than a year.
Apparently.
Yeah. All right. Well, I'll see
Okay,
you.
good.
We're
We'll
4
all
days
join together.
shy of 2 years.
Yeah.
When do we go out to Westmont's observatory, Chuck? Or
Friday the 20th.
Friday.
Okay. All right. And then on the 3rd, we'll welcome Professor Bassi, who lives in Lompoc, down to talk to us about space weather.
Okay.
Meantime, check us out, SBAU.org. We'll see you on the podcast called SBAU Astro Hour next Monday morning, which should be the 19th.
Yep. Bye.
See you later.